So hello guys, this is B and you are watching Alpha Tutorials. So today I'm going to teach you the FFT in the more simpler terms so that you can understand it with ease and you can score much better marks in your university exams. So we know that the Fourier transform helps us to transform the equations or sequence from time domain to frequency domain and vice versa. Whereas it has two methods, either to transform from time domain to sequence frequency domain or frequency domain back to time domain. That is, the two methods are basically the DFT and FFT. FFT we are gonna learn in bit while, but let us understand DFT and so that we can have a good grip on the concepts. So DFT is basically the equation methods which are helped to which helps us to transform the sequence or equations from time domain to frequency domain and vice versa. This is called as analysis equation, which helps us to transform the time domain sequence to frequency domain sequence, and this is called as synthesis equation, which helps us to transform the time frequency domain sequence back to time domain sequence. So these terms are very important to understand FFT or to what you can say to understand FFT in much more easier way. Okay, so from these terms we can generate the Twiddle factor. Twiddle factor is given by Wn is equal to e raised to minus j 2 pi by n, where n is a number of elements or number of elements in a sequence. So if we substitute the value of Twiddle factor in these two equations, we are going to get these equations. Okay, so we can see that Twiddle factor is having positive term in transforming the time domain to frequency domain, whereas it is having the negative term in transforming the frequency domain term to time domain. Okay, so this was all about DFT. Now let us understand the FFT. What is FFT? Unlike DFT, we are gonna transform the time domain sequence to frequency domain sequence and vice versa in faster way. That's why it's called as the fast Fourier transform. So fast Fourier transform can be either done in time domain and frequency domain. That is, if it is having a fast Fourier transform, then it must be having inverse fast Fourier transform. Okay, so let me write it here also. As we know, as we have DFT and IDFT, so similarly we have FFT and IFFT. So before understanding that, let us understand the term called decimation. So not going to the high level, but for now just understand that decimation is nothing but grouping into odd and even. What is that we have to group? We have to group the sequence, or we have to group the elements in the sequence based upon their index. So depending upon their index, whether it is odd or even, we have to group them or segregate them. Okay, so this is the meaning of decimation, right? So having known about decimation, so FFT can be DIFFT or DITFFT. Okay, DIFFT, sorry, DIFFT and DITFFT. Similarly, the inverse Fourier transform can also be grouped into DIFFT and DITFFT. Right. So these are the four concepts that we are going to learn through this video. Okay. So what is this DIFFT, DITFFT, DIFFT, DIT, IFFT? So yes, here I must come. So in DIFFT, we are gonna group the elements in frequency domain, and in DITFFT, we are gonna group the elements in time domain. Similarly, in DIFFT, we are gonna group the elements in frequency domain, and in DITIFFT, we are gonna group the elements in time domain. So here we are getting the time domain equation from the frequency domain equation, but depending upon whether it is DIFIFFT or DITIFFT, in DIFIFFT we are going to group the elements in frequency domain. In DITIFFT we are going to group the elements in time domain. Similarly goes for FFT. So let us understand each of them in more detail. So first we are going to learn about DIT FFT, that is decimation in time domain. So when you are given the question like solve this sequence or convert this sequence into frequency domain sequence using DIT FFT. So first learn or understand the second term FFT. What does it mean? Fourier fast Fourier transform means we are converting the time domain sequence into frequency domain sequence, right? And what is the first term telling us? DIT, decimation in time. Decimation in time means we are grouping the elements in time domain. Okay, so how does the decimation work? Let us understand by taking small steps. Okay, first let us understand the decimation DIT-FFT for two elements. Okay, so you are given with a sequence, and there are two elements. Okay, and you need to convert these elements into the frequency domain sequence, right, using fast Fourier transform, that to DIT FFT. Okay, you need to convert this into frequency domain sequence using DIT FFT. So how do we do that? So as there are only two elements that can be either one odd and one even, we don't need to segregate here. Okay, so how does the method goes? So first draw two lines. So here we need to convert the things from time domain to frequency domain. Always remember we are gonna go from left to right. This is a universal rule for every step in the FFT. Okay, and write the first element for the two elements. Okay, this is time domain, this is frequency domain. Okay, this is time domain, this is frequency domain. Write the first element x of 0, x of 1, and take one point over here and join it over here. Okay, and take one point over here and join it over here, and this will be -1, and this will be frequency domain term x of 0 and x of 1. Okay, so what does this x of 0 and x of 1 is equal to? So we can see that x of 0 is nothing but small x of 0 plus small x of 1. Okay, okay, but x of 1 is nothing but x of 0 plus x of 1 into -1, that is x of 0 minus x of 1. This is only 2-bit element. Okay, this will be every time right, that we need to always go from left to right. Okay, so now we are going to take the 4-bit element, 4 bits. In the 4 bits, so we need to convert the time domain sequence into frequency domain sequence using DIT FFT. So if you are given that, so first and foremost rule, learn the second bit, that is either either it is FFT or IFFT. First understand that thing, and if it is FFT, write down the names over here, that is time domain and frequency domain, and we must always go from left to right. So as it has 4 bits, so x of n would be x of 0, x of 1, x of 2, x of 3. So now we need to understand the decimation in time fast Fourier transform of this sequence. So first let us draw the 4 lines. Okay, 1, 2, 3, 4. This is a four lines. So now what does the decimation in time domain actually means? Okay, in 4-bit we never understand what does it actually mean. First we are gonna write all the even elements. So first comes x of 0, second comes x of 2, third comes x of 1, fourth comes x of 3. So we are going to grouping the even terms one side and odd index terms on the other sides. This is called as a decimation. So now we have to go forward. So one more thing, this two cross butterflies comes whenever there are decimations. Okay, wherever there are decimations, it starts from 2 cross. So this will be same as for these two. Here there will be -1, here there will be -1, and here we must have j. So minus j. So here we are gonna have minus j. Okay, and take the points of from each line, leaving one line in between. Draw this structure. So here comes -1, here comes -1. So you are decimating in time domain. It doesn't mean that the frequency domain is also decimated. No, it's not true. The frequency domain remains as it is: x of 0, x of 1, x of 2, x of 3. In 2-bit element, you had only one stage of computing the frequency domain sequence, whereas in 4-bit you have the two stages for computing the frequency domain sequence. First stage is to compute till here, second stage is to compute till here. Okay, so this is the 4-bit structure. So now we are going to understand the 8-bit sequence. Okay, so similarly as we did for 4-bit, first let us classify them as odd indexed and even indexed. So even indexed will be x of 0, x of 2, x of 4, x of 6. Okay, and odd index would be x of 1, x of 3, x of 5, x of 7. In this also we need to segregate them as even indexed and odd indexed. These are even indexed and these are odd indexed. Similarly, these are even indexed and these are odd indexed. So write all the even indexed from each term first. Okay, x of 0, x of 4, x of 2, x of 6. Similarly here, x of 1, x of 5, x of 3, x of 7. Okay, so in this sequence you need to write or fill this 8-bit sequence. Okay, first draw the 8 lines and start filling according to the decimation terms. First comes x of 0, second comes x of 2, x of 4, because we have got x of 4 over here. Third comes x of 2, fourth comes x of 6, sixth comes x of 1, x of 5, x of 3, x of 7. This is a decimation term for 8-bit.